Okay, so up to this point we've used trig functions to find a missing side length when we know one side and an acute angle in a right triangle. I've given you an example of the type of right triangles we've been dealing with recently, and in this situation we know that we cannot use Pythagorean theorem since we know only one side of this right triangle. We also know that our trig functions can help us solve for this missing side length by using sine, cosine, or tangent. So in this case, 35 degrees is an interior acute angle that's given, and x is opposite of that 35 degrees. 8 is your hypotenuse in that right triangle, so we know that we can find x by setting this up as the sine of 35 is equal to your opposite side length over your hypotenuse, and then cross multiplying and solving for x. But what if we have two side lengths and what we want to know is the angle measure? So in this case we know two of the side lengths, but we don't know the angle measure on the inside, and we want to know what that angle measure is inside of your right triangle. Now we could use the Pythagorean theorem, but we don't really want to know this side length, right? That doesn't really help us in terms of finding what that missing angle measure is. So how do we deal with this type of situation when we don't know the interior angle measure but we want to? In this case, here we're going to use what we call our inverse trig functions. Our inverse trig functions. And these are the buttons on your calculator that we've been looking at over the past couple weeks. You guys have asked a couple questions about them. And they're the sine, cosine, and tangent values to the -1 power. We're going to be using our second button on our calculator, second sine, second cosine, and second tangent to use for these inverse trig functions. But that's what we're going to be talking about in example 1.